So we all have played the game Flappy Bird, right? I suddenly thought of adding some spices to that game. So I created this, a machine learning based gesture controlled modified version of the game Flappy Bird, that is Flappy Plane. And in this video, I will show you how to make this game step by step from scratch, explaining every detail how they works. But there is a catch, that is, to make this project, we will not be using Python or any Python-based frameworks for the machine learning part. We will be using a machine learning library of JavaScript, that is ML5.js, which is quite underrated. And the most interesting part will be creating the model by ourselves. And you don't need to have much prior knowledge about that. If you know quite good JavaScript and React, you are ready to go. We will be deploying this project too on Netlify. And I will also be leaving the source code open on GitHub and create another branch for you so you can contribute to this game by adding some more features. You just modify and create pull requests and I will review and merge them if the features are good. So without further ado, let's get started. Alright, so first thing first, let us set up our React project. And I'm assuming you have Node.js installed. If not, please pause this video and go install that first. Now, open your terminal, go to your projects directory or wherever you want to create your project. Then write npm create void @latest. So we will be using void as our bundler. Now press enter. We have to give a project name. Let's name this Flappy Plane. Press enter. Then we have to choose the framework. For our case, it will be React. Press enter. Now we have to choose a variant or a language. So we'll be using JavaScript. Press enter and we are done. Now we have to run this following commands. Firstly, we have to change the directory to Flappy Plane. Now we have to run npm install to install our dependencies. After that, you can run the project using npm run dev, but before running the project, we'll open it using VS Code. So for that reason, write code space dot and press enter. You can see the directory Flappy Plane is now opened with VS Code. Now you can run npm run dev to run the development server. So you can see the project is started on localhost 5173. Copy this, then go to your browser and paste that here. So you can see a demo React project is created and this is a simple counter app. Now the next steps are, firstly we have to install Tailwind CSS because for styling purposes we will be using Tailwind. For that reason, go to the website of Tailwind, tailwindcss.com, then go to their docs, and here you will see the process of installing Tailwind using void. And among the steps, we have already performed the first step, that is creating our project. Now the second step, that is install Tailwind CSS. So for that reason, we'll copy this command, Ctrl C, then go to our VS Code. Now press Ctrl J to open the terminal if you are in Windows, but that may be Command J for Mac. Now paste that command here and press enter. So Tailwind CSS is installed. Now again go to the docs and the third step, that is configure void plugin, that is inside void.config.ts. In our case that will be JS. We have to import Tailwind. So copy this, then go to void.config.js, then paste that. And the final step, that is we have to include Tailwind CSS inside plugins. So copy this also, inside plugins, after React put a comma and paste that, and we are almost done. Okay, we have left with only one step, that is we have to import Tailwind CSS on our index file. For that reason, copy this also. Now go to src, then inside index.css, here you can remove all the CSS files and paste that. Save this and close this too. Now inside src we can remove the app.css file, so you can delete it. Then inside assets you can remove the react.svg, you can delete that too. And inside app.jsx you can also remove all this from here, so Control A, delete. We'll create a fresh new app component. So there is a shortcut snippet, that is RAFCE, to create React arrow function export component. We can see it has created an arrow app component for us. You can remove the React import, and to use these snippets you need an extension that is named maybe ES7 snippets or something like that. Maybe this one, ES7 JavaScript node. You can find that yourself. Okay, now let us test if the Tailwind classes are working perfectly or not. So for that we'll give a class name of text 3xl. Save this. Now go to your browser. Oh no. Okay, so as we have configured the white.config.js file, so for that reason we need to restart the server. So Control C to close the server, and again write npm run dev. Okay, here you can see the Tailwind class is working perfectly. Now, before starting our project, we need some assets. I already have downloaded the assets. These assets, I will provide the link in the description box, so you can download them from there. So now, we'll copy the assets, copy them all, and move them inside this assets directory. Okay, so now we will import all the assets one by one, because we will need all of them. So firstly, let us import city image from ./assets/city.jpg. Then import the building image from ./assets/building.png. Then we will import the plane from ./assets/plane.png. And after that we'll import the boom. What is this boom? This will, when our plane crashes, then the game is over. So at that time we'll show this image. So import boom from ./assets/boom.png. Now let us create the UI of our project. So cut this app from here, give this container a class name of minimum height of screen. Then the items inside will be flex in column direction. Then the items will be centered. Inside div we will create a paragraph tag. In this paragraph we will provide the direction how to play the game. So that is press space to control the game. And let us wrap this space with a span tag and make this class name font bold. And this paragraph also give this a class name of text base, margin bottom of 2 and margin top of, let's say, 6. Now if we go, you can see this direction here. Now after that we will create the canvas of our game, I mean the image or the city image above which the plane will float. So for that reason let us create the container, and in this container we will provide the background image. So for that reason give it a custom style with the properties background image. Then give backticks for dynamic string. Now provide the URL here. So that is the city image. And the background repeat, it will be no repeat. Give this a height of, let's say, 400 pixels, and give this a width of 600 pixels, and the background size, make it cover. I think we are done, but let's give it a class name too. So class name object contain, make it relative, because the contents inside this div will be absolute relative to this container. Then give this a border of 2, and the border color will be cyan 600, make it rounded, smaller, and give it a shadow medium. Now let us go and see how that looks. Okay, this looks fine, but give this div another class name of margin top of 6. Okay, now this is perfect, but you can see this image is too much bright. For that reason, we will create a subtle dark overlay on the background image, so that will make our game elements more visible, and that will give it a nicer atmospheric look. So for that reason, go back here, and inside this div create another div with no contents inside. Give it a class name of absolute, then insert 0, background black, and opacity of, let's say, 40. Now save this. Now you can see a subtle dark overlay is created above this background image. So now our game elements will be more visible and bright. After this, firstly we'll show the score here. So let us go and create the score component. So create a h2 tag and write score, and here we will dynamically show the scores. So for that reason, we have to create a state for the scores. So const score set score is equal to use state, import use state from React, then initially the score will be 0, and here we'll pass the score state. Now give this a class name. So left 3, top 3, and it will be absolute obviously, then text cyan of, let's make it 800, then text excel, give it a z index of 40, font semi-bold, then background blue 200, give it a padding of 1, and rounded large. Save this and go. Here you can see a nice score section for your game. Now after that, we'll create the elements. So first of all, let us create the plane. So create an image tag. Inside src, we'll pass the plane that we imported earlier. Give it a all tag plane, and also a class name of z10, and it will be absolute obviously, height of 10, then width 20, then left 20, transition transform, give it a duration 150, and animation of ease out. Now if we go, you can see the plane here, but we don't want the plane to be above initially. Initially the plane should be in the middle of the screen or the middle of the canvas. So before doing that, I want to explain you something, that is, Let's say this is our canvas. The height of the canvas is 400 pixels and the width it is 600 pixels. Now, what should be the initial position of the plane? You may say in the middle of the canvas, so that will be 200 pixels. As the total height is 400, so the middle position will be obviously 200 pixels. Let's say this is our plane. So this is 200 pixels from top. But after starting the game, the plane's position will decrease each second, isn't it? Let's say you started the game and the plane's position started decreasing. So for that reason, we will keep the plane a little bit above of 200 pixel. That may be 170 or 175 pixels. So the initial position of the plane from top will be, let's say, 175 pixels. And as this position is dynamic, so the state of the position will change each second after starting the game. For that reason, that will be inside a state. So let us create the state. Let's name it plane position from top, then set plane position from top equal to use state, and we assumed it to be 175 pixel. And we have to pass this state inside this image. So give it a style that will be transform, then inside backticks this will translate to y-axis by the plane's position from top, then pixels. Now save this and you can see the plane's position is changed from the top to the middle position. Now after this we will create the buildings. So for that reason, again go to your file, here create a container first, then inside this we will create two images. We'll provide the same image, this same image of building, but those will be vertically opposite. One will be upside down and another will be normal position. So pass the image here of building and give it a alt tag and also a class name. So both will be of width, let's say 24, height of 40, and both will be absolute, but the first one that will be in normal position, bottom 0, and the second one will transform it by minus scale y 100. So this will be flipped, that means the upside down. Now if you go, you can see both the buildings, but for this case, for buildings also, initially their position will be on the right side of the screen, I mean the rightmost side of the screen. So let us fix that too. So we will also need a state for the buildings. So const building position and set building position equal to use state. So initially from right their position will be 0. So we have to pass this 2 on the buildings. So let us create a custom style for this two buildings. So give this a style of right, then it will be the dynamic building position, then pixel. Now if you save this, you can see the position of the buildings has been changed and now this looks perfect. Now let us give this the functionality. So for this reason we need two more states. Firstly, the first state will be to check if the game is over or not. So is over, set is over, is equal to use state, that will be false. Then if the game is started or not, so const is started, then set is started is equal to use state, it will be also false initially. Now if the game is over, then I told you that I will show this image. So for that reason, let us create that too. So below this div, the overlay, here we'll create a component if the game is over. So if is over, we will return a container and give this a class name of absolute, then height full, width full, make it flex, flex column, items center, then justify center to, and give it a z index of 50. And also we will provide the background image, that is this one, boom, here. So for that reason, give it a custom style and background image, backticks, then URL, pass the image here, then background repeat of no repeat, then background size contain, and left give it 35 pixels. And inside this container we'll show some text. First one, let's say 911, it's an emergency. Then give this a paragraph, here we'll show the score. So your score, that is the final score obviously, and here simply we'll pass the score state. Now give this class names. So class name of text for Excel and font bold, and this paragraph also class name of text LG, that is large, then text till of 500, then font semi bold, and we are done. We can see this after we implement the functionality to this game. So let us add the functionality. So firstly we will animate the buildings. So these buildings, they will go from right to left, isn't it? I think you have played Flappy Plane, and there you have seen the the poles go from the right to left. So for that reason, we will create a use effect hook, import use effect from React, give it a callback function and a dependency array. Firstly, create an ID for the animation. So let's say animation frame ID. Now we'll create a function to animate the building. So const animate building is equal to, now inside this function we will set the building position to, firstly let us get the previous position, then we will return that if the previous position, that is less than equal to 500, then we will simply return the previous position plus 1. So let me explain you this. So the buildings are here. So this is the 0th position, let's say, and this is 600, as this total is 600 pixel. So this is 600, this is 0. So somewhere near here that will be 500 pixels, isn't it? And you can see this building has a width. So when this building reaches this 500 position, I mean here, then what should we do? Then again we should start over, isn't it? So these buildings will go from here and when it reaches 500 then it again starts over. So we are simply implementing this, that is, if the position is less than equal to 500 then we are simply increasing the position of the position of the building. So you can see it was in the 0th position first and it increases the position by 1. So 1 2 3 4 5 6 7 8 9 10 11, and when this reaches 500 that means the building's position is here. At that time it again starts over. So 0 1 2 3 5. So if the previous position is less than equal to 500 then we are increasing, and if the position is greater than 500 then again we will start over. That means we will return 0, isn't it? That's what we are doing here. So until it reaches 500 it increases the position by 1, and when it reaches 500 then again it makes the position of the building to be 0. So we are simply doing that. So how this will happen? We are just simply setting the state or updating the state, but with respect to which, I mean with respect to time or something, the position of the building should increase, isn't it? So for that reason we will call a built-in browser API that is known as request animation frame. So request animation frame, and inside this we'll pass this animate building function, as simple as that. But also we will assign uh, the return of this into the animation frame ID because it will be needed for cleanup purposes. So what does this request animation frame do? It is a built-in browser API that tells the browser, hey, I want to update something like the animation on the screen before the next repaint. Please call my function just before that happens. It is similar to set interval, set timeout, but it's more efficient and more smooth. You can do this also by set timeout. I mean, you can create an interval or set interval and you give it, pass it 1000 millisecond. That means in each second the position of the building will be increased by 1 pixel. But this method, request animation frame, this does the same thing, but this do it more efficiently and more smoothly. And you can see that we are calling this animate building inside the animate building function. So this kinds of happens like recursion, and we have to also call this outside the scope. So when we will call this function, we'll call this if the game is started and if it is not over. So if the game is started and it's not over, then again we'll call that. So we'll assign that to animation frame ID, then we'll request the animation frame and simply pass the animate building function. Now why we assigned the function to this? Because after the component unmounts we have to cancel the animation to prevent any memory leaks. So for that reason simply return the cleanup function here, that is cancel animation frame and pass the animation frame ID. Now you understand why we needed this animation frame ID. And the use effect needs some dependencies, that is if the game is started or over. Now let us create the buttons to start the game or to reset the game. So below this div, create another container, give this a class name flex and gap of 6 and margin top of 4. Now there will be two buttons. First is if the game is not started, and also the game is not over. Then we will return a button that says start game, and let's give this button a class name of padding in x-axis of 3, padding in y of 2, then text teal of 400, then outline teal of let's say 400. On hover the background will be teal 400, and on hover the text will be white. Make this rounded large and give it a shadow of large, and also give outline. Now if you go, you can see this nice button, and on clicking of this button, so on click of this button, we will simply set the is started property to true. That's all. Now if you go, now if you click on start game, you can see the buildings are moving from right to left, and when it reaches 500, then it again starts over. So we are almost done. Now we just need to animate this plane. So for that reason, we will animate the plane, but before that, let us also create the reset button. I mean, if the game is over, then we need to reset all the states, isn't it? So if the game is over, then we will return a button that says reset. So give this a class name. I will copy this and paste it here. But on click of this button, firstly, we will set the building position again to 0. Then we will set the plane position from top again to 175. That is the initial position. Then we will say set is over to false. Then set is started to false too, and also set the score to 0. Again, we are initializing everything from the start if the game is over. Okay, so now let us animate the plane. So this was animate the building. Now we will animate the plane. So this will be the same as the building animation. So for that reason, firstly we'll create a use effect hook, then give it a callback function, pass the dependency array, then here also create the animate plane ID, then create the animate plane function. Now we'll set the plane position from top to, firstly we will receive the previous position. Then what we will do, that is, if the previous position is less than equal to 380, then we will return the previous position plus 0.3. Let's make it 0.4, and else we will simply return the previous position itself. So what are we doing here? Let me explain it here. Our canvas height was 400 pixel. So this is the 0th position from the top. I mean the plane's position. So this is 0. This is 175 where the plane is initially situated, and this is 400. And somewhere here it is 380. So if the plane is here, then the plane's one wing will touch this bottom side of the canvas. So at that time we need to hover the game. So if the plane's position is less than 380, what we will do, we will simply increase the plane's position from top, isn't it? So we are doing, if the previous position of the plane was less than equal to 380, then we are simply increasing the previous position by 0.4 pixel. So for that reason, the plane will fall down like this by 0.3 pixel or 0.4 pixel on each second. So until when? Until it reaches 380, because you see when it reaches 380, the one wing of the plane touches the bottom of the canvas. So at that time we need to over the game, isn't it? So for that reason we have provided this logic here. So now we have to call the request animation frame here, and we'll pass the animate plane to call it recursively, and we have to call this outside of the function also. That is, if the game is started, then we will call the request animation frame and we will pass animate plane function. And finally, when the component unmounts, we will return a cleanup function that cancels the animation frame. So we will provide simply the animate plane ID, and here it will be animate plane ID, and the use effect needs some dependency that is started. So I think we are done. Now if you click on start game, you can see the plane's position from top is increasing, and also the buildings are working perfectly. Now let us create the logic of the game over functionality and also how to control the plane. So let us firstly create the game over conditions. So here create another use effect, provide a callback function and a dependency array. Now what are the conditions of the game being over? So if one case we saw, that is when the plane reaches 380 pixel, I mean this position, then the plane's right wing that touches with the bottom of the canvas. So it will be one of the is over conditions. So if the plane position from top is greater than and equal to 380, then it is a game over condition. Or another condition will be when the plane touches the top of the canvas. But one thing you will notice here, that the left wing of the plane, it is smaller than the right wing. So if the initial position is 0 here, then what may be the width of the left wing? I mean, here you saw when it was on 380, the right wing touched the bottom of the canvas. So in case of the top position, as the right wing seems to be twice of the left wing, so for that reason I think when the plane position from top is 10, then the left wing will touch the top of the screen or top of the canvas. So the other condition will be, or the plane position from top is less than 10, or you can say less than equal to 10. So these are the condition of the plane to be touching the top of the canvas or touching the bottom of the canvas. Now when the plane touches the buildings, at that time also the game will be over. So when the plane can touch the building? So let me firstly remove this. So I have calculated that this building's height is 150 and the plane remains here, and when the building comes here, the buildings they remain at 375 pixels. So this position, it is 375 pixel. So one condition for the game to be over is the plane touching the top building. So as I told that this building's height is 150. So when this plane goes above 150 and also the building is at 375 pixels or less than 375 pixels, then it will be a game over condition. Let me make this clear again. The building's height is 150, and when the buildings is at this position, I mean the building was initially here and the position is increasing, and at a certain time it reaches this 375. So at 375 the plane and the buildings are at front to front situation. So at that time, if the plane's position from top is less than 150, I mean the plane stays here, so then the plane will touch the building. So this will be a game over condition. So the condition will be the plane's position from top is less than 150 and also the building's position is greater than or equal to 375. So let me write this, that is the plane position from top is less than 150 and the building position is greater than 375. So this is the condition when the plane touches the top building. Now what will be the condition when the plane touches the bottom building? So one case remains similar, that is the buildings remain at 375 but the plane's position goes below. I have calculated it, it is 265. So this is 150 and this is 115. So total is 265. So total this is 265. So when the plane's position from top is 265, I mean this position here, then it touches the bottom building. So the condition will be when the buildings are at 375 and the plane from top is 265, then it touches the bottom building. So let us write this condition also, that is, or plane position from top, I said it will be greater than 265, and then the building position same as previous, it will be greater than 375. So these four are the conditions for the game to be over. So if these cases happen, then we'll simply make the is over to true, and also we'll make the set is started to false, and the dependency array will provide the building position and also the plane position from the top. Now if you save this and go to the browser and start the game, you can see it touched the building and the game is over. And you can reset this, and again all the position of all components are set to initial position again. Now let us handle the player input, I mean the control system for the game. So we will be controlling the position of the plane by space. So let us create a function. So const handle space press equal to, it will receive an event, then if the event dot key is equal to, if it is a space, then firstly let us event dot prevent default, then we'll simply set the plane's position from the top to firstly receive the previous position, then we'll simply return previous position minus 20. That means after the game is started, the plane's position keep increasing, but when the space is pressed, then the plane's position will be decreasing. But we don't want the plane to be outside of the canvas. That means if someone presses the space for too long, then the plane may reach out from the top of the canvas. So let us create a boundary limit. So if previous pose or previous position is greater than 10, only that time we'll return this, and if it reaches 10, then it actually matches with this condition, that is the game over condition. So at the time the game will be over. Now let us call this function inside a use effect hook, pass the callback and the dependency array. So firstly, if the game is started and the game is not over, at that time we'll add an event listener. So window dot add event listener, we'll be listening to key down, and when this happens we'll simply call the handle space press. And also we have to write the cleanup function when the components unmounts to prevent any memory leakage. So we'll simply return window dot now remove event listener. So on key down we'll simply remove this, and this needs some dependencies. First one is over and is started. Now let us see if this works or not. So let us start the game, press space, and you can see you can control the game. And also when it touches the buildings, then the game is over, and you can reset this too. So we are almost done. We are only left with this score functionality. So for that reason, now let us create the functionality for the score. So write use effect. Now if the game is started and the building position is equal to 500, then we'll simply set the score to be, firstly we'll receive the previous score and return previous score plus 1. So let me explain you this, what is happening here. Firstly let us pass the dependencies that are building position and also is started. So the buildings are initially here on 0th position, and when they reach 500, that means the plane has crossed the buildings, isn't it? So again this will start from here. So when the plane crosses one building or the building crosses plane, then the score increases. Again, the building position increase, and when it reaches 500, then it crosses the plane, and again the score increases. So like this, when the building reaches at this 500 pixel, at that time we are increasing the score. So we are simply increasing. If the building position is equal to 500, that means it has reached to 500 pixels, then we are increasing the score. Now let us test if it works or not. So you can see the score is increasing. And when the plane reaches the top, then the game is over. And here, as I have told you that I will keep the repository open. So you can add some more features, like when the score increases, then the speed of the buildings will increase, or the buildings height width will increase, or maybe the speed of the plane will also increase. So you can add some more features to it. So the next section is going to be about the gesture control part. So for that reason, let me give you a quick overview and a brief about what is machine learning and what is image classification. So machine learning is a way for computers to learn from data instead of being explicitly programmed. That means, let's say if there are two images, like if there is an image of a cat and an image of a dog, you can explicitly program that this is a cat and this is a dog. But if you bring some other images of cat here, then your program wouldn't understand that what is that image of, because you explicitly program that the name cat, it is only for this image, not for any other cat image. So that is called explicit programming. But without doing this, if you do like something like, if you create a model, what is a model? A model is something like an executable you can think of, or a program simply. So you give the model a bunch of cat images and tell the model that these kinds of images are of cats, and you also provide the model a bunch of dog images and say the model that these are images of dogs. So this is our model. Now the model, what it does, it finds or matches patterns between the images. So now when you give any random image, like let's say you give any random cat image here, then the model can successfully say if this is a cat or if this is a dog. But no model can actually 100% predict if something is a cat or dog. So it may say that I am 80% sure this is a cat. That means there is 20% chance of this to be a dog. But as the percentage of cat is higher, so we will assume that this is a cat. And if you provide more images here, like if you provide 1000 to millions of image, then this percentage will increase. So now we are not explicitly defining something as a definite animal. We are feeding a model with a bunch of images, then the model creates or develops patterns between those images. And then if you provide the model with some random cat or dog image, then the model can predict or guess or actually classify that if this is a cat or if this is a dog. So the gesture control part of our today's game will be on top of this concept. So let us quickly go and create our model. So to create our model, we will go to a website named Teachable Machines. So Teachable Machine is a web-based tool that makes creating machine learning models fast, easy, and accessible to everyone. This was a project from Google from maybe 2015. It still works more than enough for like small projects. Now click on Get Started. So we'll be creating an image project. So click on Image Project and click on the Standard Image Model. Now there will be two classes, because we'll make the gesture control system in two different ways. Firstly for open hand and another is for fist. When the hand is open, then the plane will go up. That means it will work same as when you press the space button. And if it is fist, then the plane will do nothing. That means it will go down by itself. So let us create the class name. First one, let's say open hand, press enter, and the second one, let's say fist, press enter. Now you can upload some images of your hand open, or you can connect it to your webcam and capture some images. So I'll go with webcam, click on here, now allow, now hold to record. Capture as many image as you can, because the more image you can feed the model, the more it will work perfectly and accurately. So I think 100 is enough. Now for the fist, again click on webcam. Now make fist. Now simply click on train model. So after training is finished, now you can check if your model works perfectly here or not. Here you can see it can 100% accurately predict that if it is a hand or fist. So our model is working perfectly. Now we will export the model. So click on export model. Now click on upload my model. It will be uploaded on your drive. After the upload is finished, now here you will get a shareable link. So this is a public link by which you can access and use your model from your project. So copy this link and save it somewhere. And now go to your project. Now we will install ML5 to actually use our model. So search npm ml5. We will use this npm package. So copy this, press Ctrl J to open the terminal and paste that here. So I tried to install the ML5 package by npm, but it created a lot of dependency hells. I tried more than hours and it became just worse. But now I figured out that they have updated the ML5 library and it has a lot of dependency issues. So better let's use the CDN and an older version of ML5 probably. So again go to ML5 npm. If you scroll down a little bit, you can see by using CDN you can use a particular version of the ML5. So copy this script tag and go to your code on index.html. Here inside the head section you just paste it and change the version to 1.0.1. So this is the most stable version that worked for me. I think that will work for you too. Now just save it. Now before we dive into the actual gesture recognition mode, I think it's super important we understand why we chose ML5 and how it actually works under the hood. So again, let's open the whiteboard. So here you saw earlier that we trained the model using cats and dogs. But for our case, we trained the model by feeding it a bunch of fist and open hand images. So now our new model, let's say this is our model. Inside the open hand class, there are a bunch of open hand images. And inside the fist class, there is a bunch of fist images. So now if I provide any random person's open hand, then this model can predict that if it's an open hand or it's an fist. So let's say if I provide him the open hand, it may now give a result that will contain the open hand confidence of, let's say, maybe 95% and confidence of fist maybe of 5%. So this is the result. Now you may question that how we will feed the new image to the model. So for this reason, we are going to use the ML5. So first of all, why ML5.js? There are other JavaScript libraries too, like TensorFlow.js. So first and most importantly, your data never leaves your browser. Like if this is your browser, this model runs on the browser. But when you are using traditional cloud-based AI services, So those AI models are hosted on some server. So first of all, you need to call the server, or you need to provide this image to the server, then the server will reply back. So there is a HTTP call in the middle, and it hampers the speed and performance. So obviously ML5 is, or the browser based model execution is way more fast. Here everything runs locally. There is no network latency and no waiting for your gesture to travel to a server and get back. Because in a game, every millisecond matters, isn't it? And finally, it also works offline. So once the model is loaded, then if the network is gone or the internet is gone, no problem. The gesture recognition keeps working. And finally, ML5.js, it's actually built over TensorFlow.js. That means it's kind of a wrapper of TensorFlow.js and also making the functions way more easier and more understandable. Now, what we are going to do with ML5.js? So we have the model, right? We have the URL of the model. So there is certain URL that we got from the Teachable Machine website. So let's say this is the model URL. Now what we are going to do with ML5, firstly we will create a classifier, as we are going to classify if this is an open hand or if this is an fist. So firstly we will create the classifier. So let's say const classifier equal to, here we will call ML5 dot. Now ML5 provides a function that is image classifier. You can read more about ML5 by going to their official website. So this provides a function image classifier, and inside that function we will just simply pass the URL of the model. So this is the function image classifier. Inside we will pass the URL of the model. So now this classifier object holds this model. Now simply we can classify any image using this classifier. So now what we will do, using this classifier, there is a function that is classify function. So classifier.classify, here we will pass the image. But in our case, as we are doing this real time, for this reason we have to pass the reference of the video. That means we will create a ref, or that may be the video ref, using the useref function of React. Then we'll simply pass the reference video ref dot current. And if this was not real time, you could also use this for any particular image. In that case, you just need to pass image instead of the video ref. Now it will do the job, but we also need to know the results. So this function also receives a callback, and inside the callback there are two parameters. Firstly, the results, and secondly, the error. Now here, if we console log the result, we will see this result. So this will be in the form of an object where the open hand class will have this confidence and the fist class will have this confidence, and that will vary for each video ref. I mean, the video is continuously running, so we are classifying in real time. If you open your hand, then it will detect it is open hand, and if it is a fist, it will detect it's an fist. So we are going to accomplish this using only these two lines of code. So now let us go and create our video element first. So inside src, create a new folder, name it components, and inside components create a new file, name it video.jsx, again RAFCE, to create the arrow functional export component. You can remove the React import from here. Now give this div a class name of minimum height of screen, flex in column direction, items inside will be center, margin top of 10, and a gap of 4. Now inside this div, create a text for the instruction. I have copied the text, that is open hand for up. That means when you are showing an open hand, then the plane will go up, and when it's a fist, then the plane will go down. Give it a class name of text to Excel, then font semibold. Below this h2 tag, create a div, give this a class name of relative. Now create the video element. So give this a width of 500, give this a height of 480, then class name, give it a border, make the border cyan 600 and make it rounded Excel. Also we want the video to automatically play, so we'll give this autoplay and also muted. So now create the video ref. So const video ref equal to use ref. Initially it will be null, and inside the video we will pass the ref. So when the video is open, we will instantly start classifying. So for that reason, when this component mounts, at that time we need to load the model. And after loading the model, you saw that we got the classifier. So here from the model, passing it inside ml5.image classifier, we got the classifier. So we have to also create a state for the classifier too. So now const classifier set classifier equal to use state null. Also create a state for the loading. So const loading set loading equal to use state false. And also for the result that we will create from the classifier. So const result set result is equal to use state null. So I told you earlier that we'll get the result in this format. So this open hand and the fist with their confidence will be returned from this classify function. So as we want to load the model when the component mounts, for that reason we'll create a use effect hook. Give this a dependency array. Now create a function const load model equal to, it will be asynchronous. Now simply call the load model function. So what will be inside the load model? Firstly, we'll get the classifier from ml5. Here we saw, firstly we loaded the classifier from ml5.image classifier. So let us create the classifier const. Let's say loaded classifier equal to await. Now as we haven't installed ml5 as a npm package, we provided it through CDN. So for that reason, we load packages from CDN using window. So window.ml5.image classifier. Now inside this you have to paste the model that you copied earlier. I copied it and I kept it here. So I will simply copy this, then paste it here inside, obviously quotation, and after this slash you have to write model.json. After loading the model, here you can pass a callback function and simply console log that model loaded. And obviously before loading the model, here you have to set the loading state to true, and after loading is done, here set the loading to again false. Then we'll set the classifier to this loaded classifier, and you can wrap this inside try catch block. So try catch, paste it inside try, and inside catch simply console.error say model loading failed, and also pass the error, and also set loading to false if any error occurs. Now we need three more functions. First of all, start video function. So const start video. When the model will be loaded, then the video will be automatically started. So for that reason, we will have to create this function. So start video is equal to, we'll create this. Then also we have to create the stop video function. I mean, when we don't want to play using the gesture control system, then we need to stop the video. So const stop video is equal to, after that the final and the most important function, that is classifying the gesture. So const classify gesture is equal to, so we will create these functions one by one. Firstly, let us create the start video function. So firstly, we have to request the user for giving the camera access. For that reason, we will check if navigator dot media devices, if media device is present, and navigator dot media devices dot get user media. So these are the function to request access to those media devices. Then we will do navigator dot media devices dot get user media. Now we will pass video true. So this prompts the user for permission to use their camera, and video true means we only want the video stream, we don't want microphone. So if granted, it will return a media stream object. So dot, then we will receive the media stream. Now give a callback. So if video ref dot current, so stream is the live video data, and video ref dot current is this ref that we created earlier. Now we will simply assign this stream or the video data to this video ref dot current. So video ref dot current, we will assign this to the source object equal to stream. Now when the browser has loaded all the information, that means video ref dot current dot on loaded metadata equal to, we'll starting playing the video stream. So video ref dot current dot play will start playing the stream. Then after that we will call the classify gesture function. So if the video is started, we will call the classify gesture function. But when we will call the start video function, we will call the start video function when the model is loaded. So here inside the callback, here simply we will call the start video function, start video. Let me explain the process again. We will firstly loading the model. Then if the model is loaded, we are calling the start video function. Then the video is starting. After the video has started, we are calling the classify gesture function. So now we will start classifying the gesture. But before that, let us handle the errors also. So dot catch, if any error occurs while playing the video, then we will get the error, and simply we will log the error. So console dot error accessing the camera, and we will simply pass the error here. And we will use another state for actually tracking if the video is started or not. You will see why this is needed later. So is video started, set is video started equal to use state false, and we will pass this to the dependency array of the use effect where we are loading the model. That means if the video is started, then we are fresh loading the model again. And here before classify gesture we will say that the video is started successfully. So we'll say set video started is true. Now let us create the classify gesture function. So here we will firstly check if there is classifier. That means here we are setting the classifier after we are loading the classifier. So if classifier is present, and also if video ref dot current also video ref is present, then simply we will classifier dot classify. As I showed you before, that classifier has a function that is classifier. It receives firstly the video ref dot current. In our case we are passing the video ref because we are classifying in real time, but you also could use any image or pass an image here. Then you will get a result and a error in a callback. So firstly we will pass the video ref dot current here. So it will analyze the video ref dot current. That means the stream that we pass to video ref dot current dot source object. So it will analyze it and it will check if open hand or fist is present in front of the camera. So according to that it will classify. Then after classifying it will provide us with a result and also error. I'll show you what this results object contain. First of all, let us handle the error case. So if any error occurs, we'll simply console.error that classification error, and we'll also pass the error here, and also we'll return from the function. And let's for now we simply console log the results. And to run this continuously, we will create a set timeout. Here we will call this classify gesture function and pass a delay of 30 milliseconds to run this in loop. So now this will run like a recursion kind of. So we are getting a timeout of 30 milliseconds. That is, in every 30 milliseconds this function will be called and we will classify the gesture. Now let us pass this component inside the parent in app.jsx. So for that reason, firstly let us create a state that const is video on set is video on equal to use state. It will be false initially. Now let us pass the video component here. So firstly wrap this up, then create another div and here paste this, and in the top here give curly braces and say if is video on, then we will show the video element. So here we will pass the video and import this from ./component/video. Actually wrap this video with a container and give it a class name of flex minimum height of screen and flex in column direction, and give a class to the parent container also. So give this flex minimum height of screen and justify evenly, and pass the states that you just created, that is video on and set is video on, to this video component. So is video on equal to is video on, and also we'll pass the set is video on. Now we will receive this as props here. So is video on and set is video on. Now we are calling start video directly here, but we will firstly give it a check that if is video on, then we will start the video. And we have to pass this is video on variable to this dependency array, and also create another use effect hook here here pass the is video on, and inside if is video on, then we'll start the video, and else we'll stop the video. But we still haven't created the stop video function. Let us just create that stop video function now. So firstly we'll check that if video ref dot current is present, so it checks the DOM element that was holding the live cam feed, and also video ref dot current dot source object. So the source object was containing the media stream that was set earlier by start video. Here you can see inside source object we assign the stream. So the video stream is inside this source object. Now we will firstly get all the tracks. There may be multiple tracks, though we for now only using the video track, but if somebody uses audio track, I mean for safety we'll get all the tracks firstly. So const tracks equal to video ref dot current dot source object dot get tracks. So we are getting all the tracks. Then tracks dot for each we will get a single track. Then we'll simply stop track dot stop, as simple as that. And after that we will set the video ref dot current dot source object to null, where we assigned the stream earlier. So this is very simple. And if you don't understand any of this, like stop video or start video, these are not so much important. Only the logic that is powering the game, that is the important thing. So you may copy this if you need. I will provide the GitHub link of this project in the description box. Now here below we'll create the button to stop the video. So if the video is on, then we will return a button. So this will say close gesture control, and we haven't created any button to open the gesture control. Also we'll create that. So firstly let us create this button. So give it a class name of margin top of 4, then padding in x-axis of 3, padding in y-axis of 2, then outline, make it, let's say, rows 500, then text rows of 500. On hover, make the text white, make it rounded large, give it a shadow medium, and also make it outline. And on click of this function we will simply on click. So here firstly we will set the is video on to false, and also stop the video. So we'll call the stop video function, as simple as that. And here in app.jsx we have to create the button to actually open the gesture control. Here in this div where the start game button and the reset button is present, we will say if not is video on, if the video is not on, then we will pass a button. So button that will say gesture control, and you can paste an emoji here too if you want. Then we'll give this a class name. I will simply copy this class name from here and paste that here. And on click of this button we will set the is video on to true. Now let us start our development server using npm run dev, and let's see if this works or not. So here you can see the gesture control. Okay, I think I have forgotten some class name. So here in this gesture control remove this empty4, and also on hover the background will be rows of, let's say, 600, and give this class name to this close gesture control to here, paste that. Now again start the development server, npm run dev. Now click on gesture control. So you can see the video is working perfectly. If I inspect this and open console, you can see there is bunch of logs, because here you can see bunch of logs, because uh, in the video element or in the video component here we are logging the results after classifying the gesture. So if you open any result from here, you will see the label. Here you can see fist and also the confidence, also the label open hand and the confidence of that. So now after we have got the result, now let us close this and let's see if it works. Yes, the close video function also works perfectly. And one thing, that is, try to run this game on any Chromium based browser, because I tried to run this on Firefox. It didn't work as I expected. There it actually failed to run the backend WebGL for the browser to run the models. So I think this is not compatible for Firefox or any other browser which are not Chromium based. Now we will add logic to control this plane using the gesture control. Firstly, go to app.jsx, create a new state here, that is const fist set fist equal to use state, we will say true. So our logic will be, when the fist is in front of the camera, then nothing will happen. That means the plane will free fall. And when the hand is open, then the plane will go up. So for that reason, we are setting the fist as true, as normally the plane free falls if we don't press any button or don't do anything. So for that reason, we keep the fist state as true initially. And firstly, let us pass the uh, set fist to the video component and also receive that here. We'll need that later. And for controlling the plane here, let us create another use effect hook. Use effect. So if no fist, that means if hand is open, then we'll set the plane position from top to, firstly we'll receive the previous position and then we will return. Firstly, let's calculate the new position, that will be equal to the previous position minus 40, and we'll return the new position. If it is greater than 0, then we'll return the new position, and else we'll simply return 0. And here we have to pass a dependency array, that is fist. That means if I go to the whiteboard again, you saw here that when we are pressing space, then the plane was going upward, isn't it? You saw it in the code. Here you saw, but in that case we are reducing the position by 20 pixels. But in this case, as detecting hand, it could be a little bit complex and difficult, and it may take some time. For that reason, I have said that, or said this as minus 40. So we are simply reducing the position from top. So when that is not fist, that means that is open hand. So when the hand is open, then the plane will go to top, and if it is a fist, then the plane will go down automatically. Now this is the simple and only logic we needed for this game. Now we have to simply set this fist according to the result we will get from this classify gesture function. So you saw that the classify gesture function had a results object, if you see again. So this is the results array that contains two objects. So one thing you can notice, that the class with the higher confidence will be on the 0th position of the array, and the class or the label with the lower confidence will be the first position. So from this we can create our logic here. So cut this log. We will say if results 0 dot label equal. If it is fist, then we'll simply set the fist that we are importing here through props. We'll set this to true. So what does this mean? Results 0th element. This means that fist has the higher confidence. So the detected element from the video or the video's source object is a fist. So we are setting the fist equal to true. Else it will be an open hand. So we'll set the fist to false. And that's all. And we will create another state result. We already have created that. So now we will show this result here. So below this div, create another div, give it a class name of absolute, height of 24, width of 48, border of let's say 3 pixels, then make the border green, make it green 400, then top 4, left 4 and padding 1. Now inside this div, firstly check if it is loading, and then if no result is present, so are we setting the result? No, we haven't set the result. So firstly here set the result to this results. So now if loading and no result is present, then we will return a h2 tag and write please wait and give it a beer line break and say loading. Give this h2 a class name of text large, then font semi-bold and text green 500. So if it's not loading and also result is present, then we will return. So let us give a check. If result is present, then we will return an empty fragment. Firstly here give it a h1 and we'll say gesture to result 0 dot label, then the confidence of this, so confidence to result 0th element dot confidence dot to fixed to up to 2 decimals. So give this to a class name of text small, font semi-bold and also text green of let's say 500. Now create another two h1 tags. I will simply copy and paste this here, Control Shift down arrow, and simply change the green color to red. So these two are for the lower confidence class and these two for the higher confidence class. And here it is giving an error. You can simply return an empty fragment here. So this was all. Now let us check if this works perfectly or not. So I will start gesture control, and here you can see model is loaded and you can see it's working perfectly. It's open hand, now it's fist, open hand and fist. Go to your code and you have to check when the plane was moving up. So here you can see if no fist or the hand is open, then the plane would go up by 40 pixels. So this was only running if it was open hand, but we also need to check that if the game is started. So you also need to check if it is started, and also we need to check if the game is not over. So we need to provide these dependencies also here, is started and also is over. Now if we go, so let us reset. Now you can see it's not doing anything. So if I start the game now, so you can see that it's working perfectly. So now we will be working on deploying this project on Netlify. So firstly, go to Netlify, search Netlify online, go to the first option. If you don't have an account, just sign up. I will just go with login. Now after logging in, firstly, let's go to your project. Here, open your terminal, close the development server. So we'll firstly build the project. So simply one command, npm run build. So build is successful. You can see here a new folder named dist. It is created. Now we'll simply drag and drop this folder to Netlify. So you can right click on dist and click on reveal in file explorer. So you can see it is opened in file explorer. Now go to Netlify again. Here click on add new project and click on deploy manually. And here you can see drag and drop your project output folder here. So simply just open the file explorer and drag and drop this dist folder here. And you can see uploading, and please don't refresh while it is uploading. So you can see it is successfully deployed, and here you can also see a public link of your project. You can also customize this link. Just go to project configuration here, then click change project name, and here you can choose a custom name. Let's name it Flappy-Plane. Now just save. So this project name is already taken, so you can add random numbers with it. So save. So now your public URL is also changed. So click on that. So it's working perfectly. Now let us try to play it with space. So it is working perfectly. Now let's try to play it with gesture control. So I'll click on gesture control, allow the cameras. Let's wait when the model is loaded. So the model is loaded. You can see the gesture and the confidence. Now let us start the game. So you can see it's also working perfectly. So that was all about today, and I will provide the link of the repository on the description box. And I have said that I will keep the repository as public. You can contribute and you can add some more features. If I find the features are good enough, then I will merge them. You may add some more difficulty levels, and like if the score increases, then the speed of the plane will increase, and also the buildings speed will increase. You may also change the shape of the building, and you may also create a separate database for like storing the score data to create a leaderboard actually. So that was all about today. I will be returning with some more interesting projects soon. So have a nice day.